Okay, they say below is the graph of f of x, which is going to be a sine x plus q. We're given h of x, which is p cos x. We're given h of g of x. G of x is straightforward. They just say which g of x is equal to tan x. So it doesn't have any variable, meaning which is complete. So it's the basic time graph, and then they say we are from 0 up until we get to what, to 360. Are drawn, and then number 1 they say determine the values of a and p. Now remember what we spoke about. We said we're going to start with the mother graph, which has a and p. So if we're to do that, let's check what is it that we're going to have. That's what we're interested in. How does a sine graph look like? I said to a learner, advice, simply take a basic sine graph and then just draw it here so that you tell them, okay, but the sine graph is supposed to look like this. So what do I expect? I expect to have something like this. And then it's going to start here at 0. It goes to maximum, it goes to minimum, and then it goes to 360. This one is sine graph. You should also draw the cos graph. Let's draw the cos graph. Maybe let's use a different color for the cos graph. Where does the cos graph start? It started 1. And then it does something like this. Okay, now they say what we should determine the values of A, P, and what, and Q. Where do we find A? We find A on sine. Where do we find Q? We find Q on what? On sine also. Let's start with the one of sine, the A and the what, and the Q. Now let's go and check our sine graph. Our sine graph is given by f of x. The other thing that is going to assist you, Lulam, is to highlight these graphs because they are main. Go and follow f of x. F of x is this one here. You can see it here, and then you highlight it and say, okay, but f of x starts from here. And then we are going with f of x, 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 f of x. This is f of x. Now you can also highlight another one with a different color. Let's take green. So we're going to highlight the other one, which is h of x. Let's highlight h of x. If I highlight h of x, I'm starting here. It goes down. And then you can clearly see there's a place whereby we have green and red. Did you see that? It's darker. Do you see that place? It's a point, what we call a point of intersection, where we have a red and a what and a green. The other one, I don't have to highlight it. As long as I have two highlighters, the other one is black. So I will call it, the other one is black. So let's check the sine graph, which is red. Where does the sine graph originally start? According to the graph that we have here, where does it start? It's supposed to start at 0. But where is this one starting? It's a problem. Remember? So we're going to tell them it means our graph was shifted how many units? So it means Q is going to be equal to what? To 2. Now, the other thing that we can talk about is the maximum and the minimum. What is the minimum value that we have? We want the amplitude because the amplitude is going to give us the A. What is the minimum value that we have? We have 1. What is the maximum value that we have? So I'm going to have 3 minus 1 divided by 2, which it gives us 1. Okay, now we want to decide whether the A is positive or the A is what is negative. Amplitude is fine, it's positive, but A can either be positive or what or negative. Now let's look at the sine graph. It's supposed to start and go up. Where did this one go? Did it go up? Where did it go? It went down, meaning which A is going to be equal to -1. Don't confuse capital letter A, which is the amplitude, and A, which is the value just before our trig ratio. We are good then. We get 1 mark for Q. We get 1 mark for A. So we'll get 1 mark for Q, 1 mark for A. Now we want P. Now P, we are going to talk about is the value just before cos. So if we want to get P, how would we get P? We need to get the amplitude of cos first. Now, what is the minimum value that you have for cos? It's -2. Ne? What is the maximum value that you have for cos? It's 2. So if we want to get the amplitude for cos, let's use a different color for cos. Cos we are using blue. Ne? So I'm going to tell them amplitude is going to be given by, we have 2 minus -2. All over 2, and then we get what? We get 2. Now, let's compare the two graphs that we have. The cos graph that they have, the cos graph that they have, original, it started at what? It started at 1. Yeah, but this one is starting, and then you should also notice this. This one is starting at 2, and then the minimum is what? It's -2. Meaning what, it was not shifted, this graph, because the minimum and the maximum have been changed. This one, if you check this one, we have a 3 and then we have a 1. But with this one, we have 2 and then we also have what? -2. Just like you will have -1 and 1. So now look at this graph. If we look at this graph, it's starting and then it's going down. Let's look at this one. This one is also starting and then it's going down. Meaning with these two graphs are exactly identical. The only thing that we have to tell them is that whatever the amplitude is, it means with our P is going to be dead. Ne? So we're going to tell them what P is going to be equal to what? To 2. Positive. Is it fine then? Next. For which values of h of x, or for which values of x is h of x going to be less than 0? What do you understand by the word less than 0? It's negative. Yeah, we want to know when is this graph going to be negative. Negative, it should appear below the x-axis. You go to your graph and then you check when the graph is appearing below the x-axis. And then h of x is the green one. You go and check when is this graph going to be appearing below the x-axis. So this is your x-axis here. Now, from below, you have above the x-axis, your graph is positive. Below the x-axis, your graph is what? Negative. Remember when we were doing that question of multiplication, we spoke about that. When the graph can appear above the x-axis, the graph can appear what? Below the x-axis. Now, when is it starting to appear below the x-axis? You check here. Starting from 9, up until you go to what? Yeah, you tell them that. Exactly that. That's correct. You tell them what the graph is below the x-axis, below the x-axis is below, up until we get to what? To 2.7. So how would you write that then? That's the question. You're going to write it as x is an element 90 up until you get to what? To 2.7. And then we'll give you 2 marks for this. Yes. Next, we want to know when is f of x going to be equal to what? To h of x. It's a point of intersection. You're going to check where these two graphs are meeting each other. Go and check where you have a green and a red. Where do you have a green and a red? You have green and red here. Angish, you have green and red here. Angish, you also have green and red here. Yeah, so what are those? What are the x values then that are making that to be possible? The first one is what? What is x here? What is x? 0. What is x here? So you're going to give them the first one. X is going to be equal to what? To 0. What is x here? 45. What is x here? X is going to be equal to what? To 360. So you're going to come and write all those values there. X is equal to 0. We give you a mark. X is equal to 45. We give you a mark. And then you can see 3 marks. Meaning this is 3 answers. X is equal to what? To 360. You give you a mark. I will still find. F of x is equal to g of x is a point of what? Of intersection. I range it only. Range f of x. As it's short, the f of x is the red one. What is the smallest value that we have for f of x? What is the biggest one that we have? So how are we going to write this? Y is an element from 1 up until to what? To 3. At least this one we got it. This is our test. You check with what did you get out of 10.